An ice cube has a stone frozen inside it. The cube floats in a beaker filled with water when the ice melts. Then, see if the ice cube is already floating in the water, its average density was less than water. Okay, that doesn't even actually matter, I think. I just wrote it as a piece of information. So, in a beaker, we have water at this level, and there's an ice cube that's floating here. Let's denote it here. And there's a stone inside this inside this ice cube. Okay, it should be picturized as something like this. It should be a little deep inside the water, right? And I'll just make this picture a little more perfect, just so it doesn't get any more confusing. All right. So at this moment, the weight of the stone is being balanced by buoyant force completely, completely. Okay. So that is an important point right now. Buoyant force has to balance the complete weight of the stone. Now, what happens is when this ice melts away, this stone will simply drop to the bottom. And in this scenario, there will be some normal force and then some buoyant force, which will be just enough, just equal to the liquid this volume of stone displaces. So this will definitely be less because the stone itself would sink in water, which means buoyant force has reduced in the second scenario. And if buoyant force has reduced, definitely water displaced will also be less, because we all know buoyant force is directly dependent on how much water you displace, is lesser. And ice itself doesn't have any impact on the level of water. So the level of water that was displaced because the stone was being held will always be greater than the level of the water that the stone itself displaces. And that's why the level will decrease. The level will decrease. This is going to be your answer.